Our goal here is to figure out mechanical energy at every position along the track that we had. In this Excel spreadsheet, here's what you'll need. You'll need your position column, your height column, your time column, and your mechanical energy column. I'm going to make these a little larger. I'm going to select the whole spreadsheet by clicking here. And let's just make this 18. You can keep whatever size you want. I just want to make sure everyone can see. We're going to need positions 0 through 135. On your lab sheet, there might be a 0 missing there, but we need it. Type in a 0, type in a 5, and instead of going all the way like 10 and 15, we can do a little shortcut. So I'm just going to do 0 and 5. You can highlight those. So click here, shift down, or you can highlight like this. So even though that's a white space, they're both currently highlighted. Even though one's white, one's gray, both of these are highlighted. Right now I have a little white crosshair, and I want that to be an all-black crosshair. If I go to the bottom right, there it is. I'm going to click that while it's all black. I'm going to scroll down, and I can see a little number. It goes 20, 25, 30, 35. We want that all the way to 135, so I'm going to go all the way down. Up too far, 220. If you set yours up the way mine is, you'll end up going to number 29. So there it is. Excel kind of repeats that pattern for us. It repeats it by 5s. From there, you've got to type in your heights and your times. I'm going to make up some numbers here. These are not accurate numbers. I'm just making stuff up so that I have something to put. So you should put your actual values. But they should look something like this. It should be 0 point something. That's crazy. I'm not going to do that number. 0.24, 0.57, 0.424. Let's just, I'm just going to copy and paste. So you should put in your actual numbers, but I'm just putting in random numbers. Either way, they should be 2 decimal places. 0.24, somewhere between 0.01 and 1.0. Okay. Times. Not sure exactly what they should look like. Actually, you know what? Yeah. Times are always going to be something like this. 0.0. There'll always be that starting point. It'll be 0.0, and then it varies depending on your experiment. Again, I'm going to make up my own. These are not accurate numbers. 0.0 something something something. 0.0 something something something. Include all the decimals displayed by your PhotoGate detector. Include all the decimals. I'm putting in random numbers. You should put in your actual numbers. But you will need them. You will need these numbers. There's your columns. Okay. Now, we can calculate mechanical energy one by one in our calculators, but Excel has a nice little feature to make it quick for us. So the equation is going to be, it looks like this, MGH. And we have all 3 of those things. So M is 0.019. That is incorrect. 0.0283, I believe, was our value. Let's see. I have it here somewhere. Yes, there's our mass. 0.0283 times 9.8 times the height. So the height that I made up is 0.23. Note that it's in column B, row 2. I'm going to say it's B2. So it highlights this, and that's my potential energy right there. Okay, so there's my potential energy term. Mass times 9.8 times height. Mass never changes, so I don't need to mess around with that, but basically B2 is going to be the first one. If you do yours exactly the way mine is, you'll have B2 as well. So Maybe go back and follow so it's the same. Whatever you want to do. We have to add the kinetic energy term, which is 0.5. Well, it's 1/2 mv squared. I don't want to mess around with that 1/2, so I'm going to go with 0.5. So that's half times m, which in our case is 0.0283 times v squared. The thing is, we don't have velocity. We used our time to get it. So instead of plugging in velocity squared, we're going to need something like this, distance over time squared. Our distance, we can't just leave d there. We need to write in the actual distance. This is the diameter of the ball bearing, so that's 0.019. We'll divide it by the time, which, in this case, time is 0.02389, but I'm going to put in C2. We'll see why a little later on. So there's half times m times v squared. It's distance over time squared. Lastly, our rotational kinetic energy term, that's 0.2, which is 0.2 is 1/5. So that's 1/5 times 0.01. 1/5 times mass times v squared. So 1/5, which is 0.2, times mass, which is 0.0283, times distance over time squared again. So it'll be the same thing we have over on the left there, 0.019 divided by C2 squared. So the caret button, if you look at your 6, you hold Shift 6. That's how you get this little caret button. Oh, it looks like I have at by mistake. That should be 2. So where this is coming from, this equation that we have here, I could probably show you the actual one. I think I've got it on the page. I do not. But it's from our notes from yesterday. It's the one we have in our notes from yesterday. So it's mgh plus 1/2 mv squared plus 1/5 mv squared. The cool thing is that now that I have this typed in Excel with the B2 and the C2, Excel is going to hand pick my height and my time from this column. So now that we have it, we just need to drag and drop. So looking for that black crosshair, all black crosshair, we go to the bottom right corner, we pull all the way down. Whoa, not that far. All the way until our 135, and there we have it. So what it does is it takes the height from the left, takes the time from the left, and it computes the whole thing for you. So here it took B2 and C2. The next one will take B3 and C3. Next one takes B4 and C4. So here we have all of our mechanical energies. We didn't have to calculate any of them in our calculator. So go ahead and write those down on your data sheet, and you're all set for the next